We are asked to determine the rate law of this reaction, and we're given a series of trials in which the concentration of the two reagents are varied and the initial rate is monitored. All right, so let's look at trials 1 and 2 because we see that the concentration of CO is held constant in those trials, and we varied the concentration of NO2. And when we look at this, we see that when we increase the concentration of NO2 by a factor of 4, the reaction rate goes up by a factor of 16. This indicates that the reaction is second order with respect to NO2. All right, so we conclude on this basis that the reaction is second order with respect to NO2. We still have to determine the reaction order with respect to carbon monoxide. All right, for reaction order with respect to carbon monoxide, we need to compare trials where the NO2 concentration is the same. So if we look up here, we see that in trial 1 and in trial 4, the concentration of NO2 is 0.1 molar, whereas the concentration of CO has increased by a factor of 2. And we compare the reaction rates of trials 1 and 3, and we see that there is no change. That tells us that this reaction is independent of the concentration of CO. We can express the rate law as the rate is equal to K times the concentration of NO2 squared and the concentration of carbon monoxide raised to the 0 power. It's 0 order in CO. It's independent of CO concentration. Therefore, we can express the rate law as the rate is equal to K times the concentration of NO2 squared.